This is video 2.3, and it's the third one in this section and the final video in this section. Today we're going to put together everything we've learned in the previous two videos to actually graph these polynomial functions. When we're graphing them, we'll use this 5-point process. The first being to determine the end behavior, then the x-intercepts and their multiplicities. We'll find the y-intercept just to give us another point. And then we're going to plot some points. And then the last thing we'll do in the end is check to make sure that we have the right number of turning points. Now, the number of turning points is going to be one less than the degree. And when we take a look at our first example, we'll see how that matches. So here's our first example, and we are given a function. Now, our function's already factored out, so that'll be nice when we're finding the x-intercepts, and we're going to go ahead and graph this. The first thing we have to determine is the end behavior. Now, the problem here is that we're already in factored form. For end behavior, I don't want it in factored form. I don't really want to multiply all of this out. That's going to take quite some time because I'm going to have to cube the x plus 1 and then multiply it by the x minus 3 and times it by another x minus 3. And it's going to take a lot of work. But let's just do a little bit of thinking. When I cube this in the end, we know we are going to be left with an x cubed somewhere because we're going to have an x times an x, which is an x squared, and we'll multiply that by another x, and there's our x cubed. Now, when I square the x minus 3, I know I'm going to have an x squared involved, and that'll be the highest exponent there. When I multiply those two together, we're going to end up with an x to the 5th power. So again, we're just really looking at those highest exponents. We can see that our highest exponent is going to be 5. Our degree here is 5. Now, since our degree is 5, it's odd. Our n is odd, and our a sub n is 1. It's positive. So we have an example here of a positive odd. This was our case 1 in our leading coefficient test. So that means, if you look back in your notes, that this graph is going to fall left and rise right. If I don't have my notes available and I'm trying to remember which way this is going to go, I think of the most basic positive odd function I can, and that will be x cubed. And remember, x cubed looks like this. So we've got the falling left and the rising right. Now we need to find the x-intercepts. The great thing is we're already in factored form. So I know that I'm going to have x plus 1 equal to 0 and x minus 3 equal to 0. So that gives me two x-intercepts, -1 and +3. We need to also think about their multiplicities. Now, the x plus 1 has a cubed with it, an odd multiplicity. That means that at x minus 1, we're going to cross on the graph. X minus 3 is squared. It has an even multiplicity, which means at x equals 3, we're going to bounce. All right, the next step, number 3, find our y-intercept. So now we're going to take 0 and we're going to put it in place of all of our x's. So we're going to get 0 plus 1 cubed times 0 minus 3 squared, which means we have 1 cubed times -3 squared, and that's going to equal 9. Let's put all this together now on our graph. The first thing I'm actually going to plot is the y-intercept, that 9. So I'm going to go to 0, 9, and put a dot. Now I'm going to graph my x-intercept. So I'm going to go to -1 and 3. I know at -1 I'm going to cross the graph, and at 3 I'm going to bounce off the graph. But now I have to decide, where am I coming from? Am I coming from below or above? So now we'll use the end behavior to help with that. I know on the left side this graph is going to end falling. On the right side, the graph is going to end rising. That means that at x equals 3, I have to bounce. So we're going to bounce and come back above. Somewhere, and we know all the way up here at 9, it's going to have to turn and come and go back down through that point there. So now we kind of have an idea. We can make a little bit smoother of a graph. And we know it's going to look something like this. Remember, this isn't going to be exact. It's just going to give us a nice picture of what our polynomial is going to look like. The last step we said is check with the number of turning points. Now, the degree here is 5. That means I should have at most 4 turning points. Now, I only have 2 turning points. But 2 is less than 4, so we're okay. Remember, it can have at most 4 turning points. We're safe because we only have 2. If we had had 6 turning points, then we know there would be a problem. Let's look at this next one. F of x equals x cubed minus 3x squared. Same process. First, our end behavior. Again, we have an odd positive function. So we're actually going to have the same, because of the cube, the same behavior here. We're going to fall on the left, and we're going to rise on the right. Now we need our x-intercepts. The problem here is that we're not in factored form. The factoring we'll use is the common factor of x squared. We'll pull that out in front, and we're left with x minus 3. So the zero product property gives me 2 zeros. 1 at 0, that's from the x squared, and 1 at 3. The 1 at 0 is squared, so it's even, so the graph is going to bounce. The 1 at 3 is odd, so the graph will cross. Now we need our y-intercepts, so we're going to plug 0 in for x. Now when we do that, everything's going to turn to 0. And now let's go ahead and plot. So again, I'm going to start with 0, 0, and put that point there first. The x-intercepts, it looks like now I only have one more point to add in, and that's at 3. The end behavior tells me that I'm going to fall to the left and rise to the right. And we're going to bounce off 0 and then come back through and cross here at 3. Now, we don't know how far to bounce down. We could pick a point in the middle here. For example, x equals 1. And we could plug a 1 in for x and see what that gives us. So let's do that. Let's find f of 1. 1 cubed minus 3 times 1 squared. So we're going to get 1 minus 3, which is negative 2. So now that's just going to kind of help give me another point there. And I know that I went low enough on my graph. So if you're not sure how far to go down or go up, you can plug in some x values in between there to help you get a better graph. Let's check our turning points now. Our degree is 3, and we have a total of 2 turning points. 1 less than the degree, so we know that we're okay. I'm going to give you another equation to try. And I want you to go ahead and try to graph this one and bring your solutions to class tomorrow. So let's go ahead and graph . this one here. F of x equals x cubed plus 3x squared minus x minus 3. Now, I'm going to give you a hint here. When you're factoring to find the x-intercepts, you're going to need to factor by grouping. My other hint is you should end up with 3 x-intercepts. So when you do step here to here, you'll need to use grouping, and you should have 3 answers. This is what we'll start class with tomorrow.